Hi, everyone. Welcome. Today, we'll be talking about how low-code enables continuous testing and DevOps. It is so great to be here with you all today. My name is Juliette MacPhail, and I'm a product manager at mabl, which is an intelligent low-code test automation solution. I've been with mabl for about 2.5 years now, and I'm currently the product manager for our browser and API testing team. And that really focuses on test creation and execution across both browser and API tests. So in this talk, I'm going to be focusing on 3 key points. The first is that test automation is really central to any effort in order to succeed in DevOps. The second is an assertion that siloed approaches to test automation don't work. And finally, that low-code automation enables us to get rid of these silos and produce better results in our quality engineering efforts. So let's dive in. So first and foremost, it is really such an exciting time to be someone who's focused on quality engineering because there are so many critical trends in the industry. And we're also realizing that quality engineering plays a critical role in this as well for enabling innovation. And whether you're looking to broaden your adoption of Agile or move to DevOps, perhaps your team wants to migrate to the cloud or shift left. Quality engineering is really ultimately an enabler for all of these key trends. And effectively, what we're trying to do in software today is accelerate the pace of innovation with quality. We really want high velocity and throughput in these pipelines, and we want to be able to create and deploy changes constantly. So whether that's through code or configuration or upgrading, or even dealing with the change that's happening with your integrated partners, because you likely consume a lot of services via API from third parties. And so we want to be able to embrace that change with velocity and throughput. Now that also needs to be under the watchful eye of a system that can ensure quality. And that's really where test automation comes into play. And we know that we're successful in implementing test automation when we have a high level of automation, but we also have high confidence in our ability to deploy changes with good quality. So this is really an interesting point, and this is also the problem that we saw in last year's DevOps report. We know that when we have a low level of test automation, we also have relatively little confidence in being able to deploy changes. And as that level of testing and deployment automation increases, we can see that confidence increases as well. And this is really key as you move towards a continuous testing model. Because despite the fact that we know we want to get to this high level of automation, so we're confident in dealing with all of that change, very few teams have realized the level of automation necessary to deploy with confidence. And we have work to do to get there. And really the risk here is that we don't realize this vision of those high velocity, high quality pipelines. Because what we have to do here is slow down the throughput in order to manage quality. And that means you have limited capacity that would be able to verify those changes from a QA perspective. And so this is the risk that we end up having this bottleneck. Despite the fact that there's been so much innovation on this side, we're not actually able to have that throughput. And so this next era really tries to overcome that. And this all starts with the assertion that if you want to automate a process, you have to build intelligence into it. And we know this intuitively in places outside of test automation. So for example, if I wanted to build a self-driving car, I wouldn't just say, okay, I'm going to build the engine, give it a set of instructions, and then just go have it drive, which is effectively what we've done historically with test automation. You would really recognize intuitively that the car has to have a lot of sensors and a lot of data. We need to use a GPS, and then you have to actually be able to read what's happening in real time when you're out on the road. And then we have to build machine learning and other models in place in order to make intelligent decisions. And then once you can do all of that, you can plug that brain into the control plane that actually automates the driving. And then we have some potential there. And effectively with test automation, that's where we're going now, right? And we're saying, look, it's not just about the drivers that can move a browser, move a mobile app, or interact with an API. Once you understand the intent of automation, you have to collect the data, analyze the data, and make good decisions in order for that automation to be effective. And so low code here is really a key tenet of quality engineering. And if we don't focus on low code, then we're likely to limit the number of people and the roles who can actually participate in quality on our teams. So when I talk about intent, we're really referring to testing the things that you would look for if you were manually testing. And we can separate that out from automation. So when the intent is actually manifested in the test itself, automation can then drive the execution of it. And we actually let mabl handle this part. So when we allow teams to focus on the intent and the functionality that they want to share, we present them with a low-code interface, and then we let the system handle that implementation. And what that means is that not only developers, but manual testers, product owners, support people, and others can all participate in quality, and we don't end up in silos. So another aspect of this is that once you separate the intent from the implementation, is that we can build a system that can be very intelligent. So as an example, let's say that the intent for a test is to submit a form, and there's a submit button on that form. Perhaps my team is looking to make some changes, and they end up changing the ID of that submit button. With more traditional test automation solutions, that test is actually going to fail because it relied on the ID in order to locate the button. But in this new era, since we're collecting so much information as we're running your tests, the system knows that even though the ID changed, the button is still there, and we actually can locate it using numerous different techniques and attributes. And the system will attempt to locate that button and proceed with the test. And when we can correctly identify that an element has changed, we'll actually update that test automatically based on the information we've learned. And that's what we call auto-healing. So we're able to accomplish this by separating intent from implementation, letting the system actually handle that implementation, and enabling people to express intent with as little code as possible. So the other important thing to note here is that so many teams have spent engineering years building out sophisticated script-based test automation frameworks, and we don't want to lose that work. And with mabl, you can import any existing Selenium test that your team may have and export those tests to Selenium IDE. So this really allows you to avoid vendor lock-in, but also leverage the hard work your team has done and incorporate intelligence and machine learning into the execution of these tests. And so that's really the technology side of low code plus intelligence. And that gives us the capability to solve a lot of the problems that we've seen with test automation in the past. However, having the technology by itself is really insufficient, because where we're going to see the benefits of this is when we can roll out these solutions organizationally and fit them in the right places with the right roles. And if we don't, we actually end up seeing a lot of failures with these initiatives, despite the fact the technology is there. So as you've seen in DevOps, the vision here is really to build intelligent automation from the very beginning to the very end of the pipeline. And that starts when you're working on a local branch for a feature or a change. And that really goes all the way through to production, and that change actually reaches production. So today we're going to talk through each of these different stages, and I'll provide you with a couple of examples of what I mean when I say it's really about figuring out who will do what at that stage. So let's start out with the code base that's local to a developer's machine. The goal of this stage is that we want to have working changes. So perhaps I create a new feature that you want to validate before actually merging that to main. In this stage, we also want to make sure that we have core end-to-end test coverage in place. So for this feature, it may not test all of the scenarios, but we're exercising that happy path. And then from a quality perspective, in this stage, we also want to have a plan. So we want to know that what testing we need to do in the future, what coverage we already have, what the risk is, and so forth, so we actually can enable our team to make those changes. And so just to give you a couple of examples, in this stage, what we believe is that the developers who is creating those changes should be executing some set of initial tests end-to-end locally. And so if you're using mabl, you can actually use the mabl command line interface. And if your team's already using Jest, you can actually automate this via the command line interface to happen on every commit. And that means that if you have a set of related tests, you can run them in an unobtrusive way, perhaps in the background, to let you know whether your changes are breaking any existing tests and if those tests are finding defects. But while you're still working locally, the goal would be to know whether or not you're breaking any of the core tasks in your application, and to have those tests help you find out whether you're introducing regressions. So this process can really happen seamlessly by running those tests in the command line automatically. And what's really important to note is that this isn't just limited to developers on your team. If you have a quality engineer who's paired with a developer, that developer can be pushing their branch right back to GitHub. And then the quality engineer can be pulling that branch down, running it locally, and beginning to get more comfortable with those changes. And next, the other thing we can be doing during this phase is that while you have your code branch, you can also create a branch for that set of tests in mabl and test those changes that will be related to the code branch. So you can see in this specific example, I have my branch, I have some tests that I've created or modified so that we're all ready to go when we reach this next step. And before we do that, we'll also want to know how much work is remaining from a testing perspective around this feature. So for example, if I was working on a workspace feature, I'd want to know what other tests are related to this feature already. Am I likely going to need to change any of those tests in order to have adequate test coverage? And in the next stage, am I going to want to add any additional tests here? And with a tool like mabl, we actually already have a coverage feature where you can search basically by page and see what tests you have related to that page. Are those good tests? Do they have enough assertions? Are they effectively validating the functionality of that page? And so you can use that feature when we're in the coding stage to get a sense of what changes you might want to make as we move forward. So let's move on to what I believe is the most pivotal point in the process for a DevOps-oriented team. And that's the moment of a pull request, meaning I have a set of changes, both from a testing perspective and a code perspective, that I'm proposing we merge into our main branch. And we have some goals here as well. So the first one is I don't want to deploy or merge something right away without sufficient testing, because once we reach that main branch, by default, and most teams, it's on its way out to the rest of an automated process for our pipeline. So the first goal here really is let's not merge something that we know is going to stop our pipeline. And so coming out of this stage, we also want to ensure that there's effective end-to-end test coverage that's related to my change. And then finally, and perhaps most subtly, we also want to know that we're setting the team up for long-term success. And I'll talk about that more in a moment. But before any of that, let's make sure we're not breaking anything before we merge this into main. So in this particular example, let's say we have a set of mabl smoke tests that run automatically and continuously as part of our build process. So as soon as you put up your PR, we're running a set of headless smoke tests. And if your build fails, you won't be able to merge that PR or get it approved. So you'll know that you're failing those core headless tests, and all of that's actually automated. So as another example, when I talked about effective test coverage, using a low-code framework like mabl, anyone can actually participate in reviewing and providing feedback on the logic of tests. Is the test actually structured correctly? Are we fully validating the feature with the right assertions? And you can see here that it's intuitive. Anyone can review this test and understand. You don't have to necessarily understand the nuances of the framework or have a development background. So we really can avoid silos here as well. But there is also an area in this type of automation where having specialized knowledge is definitely important, especially around approaches to reusability, setup, teardown, environments, and overall test coverage best practices. And that's important for making sure we're setting ourselves up for long-term success. And this is a moment where you can really have some automation expertise on the team. Perhaps you have a central automation lead that's participating here as well, and they can work with your various sprint teams to ensure that we're not incurring tech debt. So another thing that we can do at this stage from a collaboration perspective is that we can execute the regression tests that have been created before this release. And we can do all that right in our pipeline. So if your team uses preview environments or ephemeral environments where you put your changes up for PR, we can run those full regression suites and cross-browser tests at that stage. And so we actually can get all that information within the context of the PR itself. And so before I approve that change or merge those changes into the main branch, I can also review all of the testing that's happened and all the code, including whether or not we validate our core scenarios. And you also can actually click right into the detail from the PR as well. So next, we're going to hit our deployment stage. And let's say that we know everything looks good in terms of the core functionality in the code. We've gone ahead and merged those changes into our main branch. Now this is all really in our automated pipeline. And so the goal here is let's make sure that we're not going to allow defects out into production. We want to make sure that we have comprehensive testing related to our changes before any of this gets deployed. And we also want to have a broader understanding of quality beyond pass or fail. And that includes a comprehensive understanding of the change and what its impact is on quality overall. So there are a couple of examples here as well. The first is in that stage, let's make sure we can identify issues and triage them as quickly as possible. So let's say here we have a failed test. And in mabl, we actually have a button where you can create an issue in Jira directly from your test results. And when you create that issue in Jira for a test failure or a bug report, you can see that it automatically populates all of the information that a developer needs to understand the issue. And that includes the screenshot, the HAR file, the DOM snapshot, to ensure there's an understanding of the status of the product during that test failure. And this also allows you to avoid any unnecessary back and forth between teammates during the triage and investigation process. So next, let's move beyond passing and failing tests to really developing a shared view across the team in terms of quality. So mabl will automatically detect other quality issues even when your tests pass. Did we see any new JavaScript errors in our console after our latest deploy? Do we have any new broken links within the application that were a part of those tests? And for each test, we're also able to see across all of your steps what the total page load time was and how that's actually trending. So in this particular test, we can see that it took about 20% more time than it usually takes, which allows us to identify trends and performance issues early on. So now here's an example of what we can do in this stage to really focus on expanding coverage. So you all are likely familiar with this concept of data-driven testing. And once your test actually exists, with just a few clicks, I can actually add in a variety of different scenarios that I want to test using data tables in mabl. And that doesn't require writing any code, and it really allows me to multiply the coverage that I have. So adding new scenarios is really just as simple as adding a new row to this table and typing in additional values. And so again, this really focuses on making testing more accessible. Even as a product person, I can really easily contribute to this. So another exciting aspect of this is that without writing any code, you can also take advantage of libraries like Faker or Math.js. And this allows you to randomize your data to increase test coverage by creating realistic data that you can tailor to your specific use cases or scenarios, which is especially helpful if you're testing various form inputs or looking to generate test data. And we can actually also expand coverage across devices. So perhaps I'm looking to test a responsive application. So not just focusing on testing across major browsers, I'm also testing across different devices and reviewing those changes in an intelligent testing service to confirm that my application is appropriately responsive. And really, testing across mobile is becoming more critical than ever. In 2020, over 60% of US website visits actually originate on mobile devices. And historically, mobile testing is not an easy task. mabl allows your team to validate the user experience across responsive applications and deliver a seamless experience for your users, regardless of the device they may be using. And with the benefits of low code, this is also another good example where you don't have to have highly specialized automation experience. And so I hope those are some good examples of where low-code intelligent tools like mabl can help get the entire team to participate in quality, which will help you get test automation coverage and confidence that you need to help innovate quickly. and many teams are currently on this journey. And we're also really excited to see so many teams seeing an order of magnitude benefit in terms of achieving higher test coverage and reducing the maintenance burden associated with testing, and in general, reducing the amount of effort they spend on regression testing. So this is really what we're working towards. We're looking to enable the move to DevOps by integrating testing deeply within your workflows, making sure that it's fast and flexible for the entire team that works with modern stacks, whether you're running in CI/CD, using single-page application frameworks or otherwise, that everyone in the team can actually participate in quality. And we also want to ensure that the tests we build are robust and reliable. By incorporating machine learning and intelligence into automation, tests can continue to develop alongside your application. And once we have all of these key pieces, we're democratizing testing to allow everyone to build and maintain tests across the development lifecycle. So thank you all so much for your time today. I'm really looking forward to hearing all of your questions.